So we've done simultaneous by substitution. Now let's work on simultaneous by elimination. In this case, here's what you're going to do. You are going to pick one of your unknowns. You can either pick your x's or you can pick your y's. And you are going to make the coefficients, meaning the number in front of your letter, you're going to make whichever unknown you pick, you're going to make the coefficient the same. So for example, let's say if I choose x, I've got 4x on one and I've got 5x on the other. The LCM of 4 and 5 is 20. So I'm going to multiply my whole first equation by a number so I get 20x. So I'm going to times this whole thing by 5. What do you think I'm going to times that second equation by? 4. That way, I get 20x plus 10y equals 20, and I get 20x plus 12y equals 48. Do you see how now, 50. Do you see how now both my x's have the same value? So now what I'm going to do is I can either choose to add both equations or subtract both equations. If I add both equations, 20x plus 20x gives me 40x. That's not elimination. So instead, I'm going to minus both equations. So 20x minus 20x gives me 0, which is eliminated, so I can get rid of that. 10y minus 12y is minus 2y. 50 minus 48 is 2. So now y equals 2 divided by minus 2. Y equals minus 1. And now what I can do is I can take that y and plug it into either of my two original equations. Doesn't matter which one you choose. I'm just going to go with the first one. So 4x plus 2 times minus 1 equals 10. 4x minus 2 equals 10. 4x equals 12. X equals 12 divided by 4, which is 3. Here's what I want you to do. I want you to try this again, but I want you to make the y's the same. So in this case, we use the LCM of 4 and 5 to make the x's the same. I want you to use the LCM of 2 and 3 to make the y's the same. And you'll notice that when you do that, you get the same answers. So it doesn't matter which of the coefficients you choose to make the same. But that's how elimination works. So I've put up 2 questions. I want you to pause this video. I want you to give those 2 a go. Okay, in this case, you have 2 options. If you chose to make the x's the same, you are going to times this first one by 2. If you chose to make the y's the same, you're going to times only this bottom one by 3. Because the LCM of 2 and 4 is 4, and that bottom equation already has the 4 in front of the x. And the LCM between minus 3 and minus 1 is minus 3. So you only have to multiply that bottom equation by 3. So I'm going to do it both ways. So if I times that whole top equation by 2, I get 4x minus 6y equals 8, and 4x minus 3y equals 13. And now I want to minus the top equation by the bottom equation. 4x minus 4x is 0. minus 6 minus minus 3 is minus 3y. 8 minus 13 is minus 5. Oh, sorry. There we go. So minus 6 minus minus 1 is minus 5. So then y equals 1. Let me do that again. So let me try the red one first. I'm going to times that whole top equation by 2. So 4x minus 6y equals 8. And then the bottom equation stays as original. I'm going to minus the two equations from one another. I'm going to minus the top one by the bottom one, shall I say. So 4x minus 4x is 0. Minus 6 minus minus 1 is minus 5. So minus 5y. And then 8 minus 13 is minus 5. So y equals minus 5 divided by minus 5. So y equals 1. And then I plug that back in. I'm going to choose equation 2. 4x minus 1 equals 13. So 4x minus 1 equals 13. 4x is equal to 14. X is equal to 14 over 4, which is 7 over 2. Done. That was one way. That's me making the x's the same. What if I made the y's the same? In that case, I would have 2x minus 3y equals 4, because I'm not altering the top equation if I'm trying to make the y's the same. And I'm going to times the whole bottom equation by 3. 39. There we go. Now, if I want to eliminate y, I have to subtract both equations. If I add both equations, then I would get minus 3y plus minus 3y, which would give me, sorry for that glitch, which would give me minus 6y. Do you see how that doesn't work? That is an elimination. But if I chose to subtract both of them, that would give me minus 3y plus 3y, which is 0. So I want to minus the top equation by the bottom equation. So 2 minus 12 is minus 10x, and 4 minus 39 is minus 35. So x is equal to minus 35 over minus 10. And if I divide both of them by 5, I get 7 over 2. Do you see how I still end up with the same value of x? And now, when I plug that back in to one of my equations, let's go with equation 2. Nope. Let's go with equation 1, sorry. So 2 times 7 over 2 minus 3y equals 4. So 7 minus 3y is equal to 4. Minus 3y is equal to 4 minus 7. Minus 3y is equal to minus 3. Y is equal to 1. Minus 3 divided by minus 3 is 1. There you go. Still end up with the same answers. That second question, let me move it over. For this one, I'm just going to do one of them. In this case, I'm going to choose to make the y's the same. So I'm just going to times this top one by 3. When I do that, I get 9x minus 3y is equal to minus 12. The bottom one remains the same. I'm going to minus the two equations. 7x equals minus 21. So x is equal to minus 3. 9x minus 2x is 7x. Minus 12 minus 9 is minus 21. And then I divide minus 21 by 7. I'm going to stick that into equation 1, like this. So minus 9 minus y equals minus 4. So minus y is equal to 5. So y equals minus 5. Regardless of which method or which coefficient you decided to make the same, you will still end up with those two answers. And that is simultaneous equations by elimination.